In Chapter 7, we're going to be studying functions and graphs. We're going to begin here in Section 7.1 going over the definition of a function and several other related definitions and ideas that illustrate this basic idea. And it is a very basic idea. In fact, something as simple as a telephone keypad can help illustrate what we're talking about here. Almost everybody realizes that the numbers on a telephone, they're associated with letters of the alphabet. And that's mostly for things like advertising, so that you can have a word and then people dial the word, and that actually is a phone number. But that can also illustrate what we mean by the idea of a function. There are two different directions you might consider going. You might consider taking a list of numbers, like say my office phone number, 5756791, and try to turn it into letters. On the other hand, you could take some letters like for math. You want to be a math teacher or a math tutor, and you want people to be able to remember your phone number, so you figure out, I'm going to use the phone number for math. And converting from one to the other, converting from numbers to letters or from letters to numbers, one of these is much, much, much easier than the other one. And the one that's easier, that thing that makes it easy, is what we're going to use as the definition of a function. Here, if you start with numbers and try to get letters for it, it's very confusing because each number has multiple letters it could be. The number 5 could be J or K or L. 7, which one are you going to pick? P or Q or R or S? So this direction has too many possibilities, and that makes it difficult. On the other hand, if you're converting from letters to numbers, it's super simple. Each letter only has a single number. The letter F, that's the number 3. O, that's the number 6. R, definitely 7. There's no choices you have to make. There's no wondering which one it could be. It's absolutely certain what the results are. So here this is easy, and it's easy because each letter has only one number. Now you'll notice some letters have the same number they're associated with, like F goes with 3, but so does D, so does E. But that's not really a problem. It doesn't really matter too much if your starting things, letters in this case, share ending things, numbers in this case. The other direction is the problem, where you have one starting thing leads to multiple ending things. So look back at the definition of a function now, and it should make sense. A function must have no more than one output for each input. Each input you start with, there should only be at most one output. You should never have to make choices about what output it might be. It's always a certainty. Now, that input-output distinction leads to some other vocabulary words, in particular the vocabulary domain and range. Now, you really just got to keep straight which one is which. And it's kind of alphabetical order. D for domain, that's the set of allowed inputs, the things you start with. And then range, that's the set of things you end with, that you have at the end. Now that's a very simple set of definitions in this case. Like for this particular model that we liked, the domain was letters, and the range was numbers. Specifically, the numbers 2 through 9. 1 and 0 weren't on the list. But that was the domain and range in that case. Domain and range can sometimes be tricky. Like when you're talking about math, you probably are thinking equations, and if you're looking at equations, what the domain and range are is a much trickier question. Domain is almost always associated with x, and in this equation here, what you basically have to consider is, what are the allowed x's? Allowed means there might be some things that aren't allowed. And if you look at this equation, you can see that there is a number that's not allowed. X, you can put any number in there except you can't plug in 0. If you try to plug in 0 for x, you're dividing by 0. Dividing by 0 is illegal. So the domain here is anything that's not 0. You could write that out in words, but this is much more abbreviated. X not equal to 0 contains the same idea, and it's much quicker and easier to write and quicker and easier to understand. Range is a lot trickier. Range is the result you get after you plug in x. And which x? Well, any x. What if you were to plug in every possible x and you get all these different outputs? Are there any limitations on what those outputs might be? And that's a much trickier question. In fact, from equations like this, you won't actually have that question asked in intermediate algebra. We're going to only ask you that question when we've got like a picture of a telephone pad so you can see what the range is, or if we draw you a graph of the function so you can see what the range is. If you're just looking at an equation, that is too difficult of a question for intermediate algebra. If you think it through, though, and if you just absolutely have to know the answer, it turns out in this case the range is positive numbers only. When you plug into this, you cannot get negative numbers out of this expression, no matter what you plug in. And in fact, you can't even get 0 no matter what you plug in. 0 will never be an output either. A set of possible outputs is any number bigger than 0. And we usually use the letter y to stand for that. So if you could have a function described by drawing you a picture, like with a telephone keypad and described in words, or if you can have a function described as an equation, you probably don't actually like the equation one as much as the picture one. Well, that's a good news, bad news thing, because here in 7.1, a lot of the homework problems you're going to run into, they're going to present you the equations, or the functions to you, in this non-equation style like this, where they list the domain and they list the range. Here's the inputs, here's the outputs. And they draw arrows to show you what is associated with what. This input goes with that output. And suddenly you kind of wish they had equations again. Don't panic, it's actually pretty straightforward. Keep in mind the basic definition. The basic definition of a function is that each input, each element of the domain in this case, it should be tied to only a single element of the range. And if you look at the one on the left, rat, in particular, is tied to both pet and wild animal. Well, that's a single input that has 2 outputs. That violates the definition of a function. So this is not a function. On the other hand, the one on the right, every single animal listed there, cat, dog, snake, turtle, antelope, iguana, each one of those has an arrow to only a single output thing. Now, there are plenty that all go to mammal. There are plenty that all go to reptile. That's not a problem any more than it was a problem when we were talking about a telephone. The thing you're looking for is, do any of these domain elements have 2 arrows coming out? And we don't. And that's good. That means each input has a single output. That means this thing is a function. So that's how you can look at these abstract arrow diagram pictures and determine whether or not the thing you're talking about is a function. But realistically, this is a math class. Realistically, you expect most of the things you're going to be looking at will be equations. Well, there is another type of thing you could very well be looking at in a math class, and that's graphs. So, we also have to be able to take this basic definition of a function and see how it applies to looking at a graph. Here's a key idea. Input, when you're talking about a graph, input means the x-coordinates. And output means the y-coordinates. So if the basic definition says that each input should have only one output, what that translates into for a picture is each x should have only one y. So if you take a look at that circle on the left, there are a lot of places that I could draw this, but I'm going to pick over here. think about these 2 points here. This one is at 1, 2, 3, 4, 5, 6, 7, comma 1. And this one up here is at 7, comma 1, 2, 3, 4, 5, 6, 7, 8, 9, 7, comma 9. So the input 7 has an output from this graph of either 1 or 9. That's a single input with 2 outputs. That's what it looks like in the picture when a single input has more than one output. You'll have 2 points that have the same x-coordinate. And because of that, this is not a function. Now with that in mind, look at the second picture. This one here, any point that I pick anywhere on this graph, that point is the only point with that x-coordinate. So this is the only point with this x-coordinate, that's the only point with that x-coordinate, this is the only one. There aren't any second points with the same x-coordinate. Each point here has a unique x-coordinate, and that's the only time that x happens. So this one is a function. And this one is not. Now it's okay over here on the left. Each of these points has a unique x-coordinate. It's an okay on the right. But here in the middle, there are a lot of places where there are multiple points that have the same x-coordinate. These points are all -1, comma something. And -1 should only have a single comma something. This is 3 different outputs. So this one is not a function. This leads to a quick and easy visual test. This quick and easy visual test is called the vertical line test. It says, if you can draw a vertical line that touches the graph at more than one point, like in that picture over there on the left and on the right, vertical line more than one point, vertical line more than one point. Here, every vertical line only hits one point. If you can draw a vertical line that touches more than one point on the graph, then it's not the graph of a function. And one last issue talking about domain and range and how it relates to graphs. Here's a fairly simple little curvy chunk graph, just a little slice of a curve. And the question is, what's the domain of this graph? And remember, domain is x's. So you're looking at this graph and you're saying, for all the points on this graph, what are the x-coordinates? The smallest x-coordinate is over here at x equals 1, and the largest x-coordinate is over here at x equals 5. So in words, you might say the domain goes from 1 to 5. But this is a math class. We're not going to write it like that. We're going to write it using math notation. And you might write it like this. That's an acceptable way of writing it in some situations. You might write it like this. That's kind of confusing here because you're mixing up two-dimensional graphs versus one-dimensional graphs, so we'll probably try to avoid that. Or you might write your answer in what's called interval notation. Most math classes and textbooks really like interval notation. You probably got to see a lot of it back in Algebra 1. Now with range, you have to be careful. Range is y-coordinates, and up here at the top, the y-coordinate is 1. And down here at the bottom, the y-coordinate is -5. But be careful. It doesn't make sense to say that the range goes from 1 to -5. That's the wrong order. It's from the big to the small. So when you say the range and the domain, make sure you go from the small number to the big number. I mean, that's kind of common sense if you think about it, but it's easy to overlook. You're looking left to right from what we did a second ago, so now you got to realize you're looking bottom to top, -5 to 1. So you could write that in inequality form like this, or you could write it in interval notation form like that.